Okay, hello. I'm here with another programming video. So this was, I believe, 2021. So this was the AQA A-level 2021 Section B question. So if you're not familiar with Section B, you essentially have an algorithm that they give you, and you'll be asked to program that algorithm. Obviously, at AS level, you're actually given the pseudocode. In this case, you're given no pseudocode, you're just given an instruction on how the algorithm would work, like if you were to do it by hand. Then obviously you're just meant to convert this into a program solution. Now, this solution is going to be in Python, but I think, well, I mean, by looking at the problem, I can kind of see how I'm going to do it, but anyway, it should be similar for other languages. Obviously the syntax will be different, but anyway. If you're wondering on the Python version, I think this is 3.12, but all the functions I'll probably use are exactly the same. Now, like they'll function the same on most versions prior. Anyway, so a harshad number is a positive integer and it's exactly divisible by the sum of its digits. Here are the first 12 which they give you. Now it gives you an example of what a harshad number is, so in this case 36. So 36, we sum up the digits, so 3 and 6, which gives us 9. And 36 is divisible by 9 because it's 4, so therefore it's a harshad number. 300, same case, 3800, which is just 3. 300 divided by 3, which is 100. And therefore it's a harshad number. 15 isn't, because if you sum these up, so you get 5 plus 1, which is 6. 6 is obviously, 15 is obviously not divisible by 6. It'll give you a decimal. So it's not a harshad number. Now, how do we go about solving this? So I did forget to put in a detail. It did say in the problem that you can assume the user input is always a positive number, so it's a bit nice of them. I'll just write here, assume that every user input is a positive integer. So we can assume that. Now, how do we go about doing it? So the first thing, obviously we need to take an input, but what the input is I haven't even included the problem. So the problem is to compute, I'll just write problem, compute the nth harshad number. So what that means is if, well, I'll use this in this top list or list of numbers as an example. If I was to say n is 5, the 5th harshad number is 5. If I was to say n is 12, then the 12th harshad number is 18. So we need to find the nth harshad number, for example. And the test case I believe was 600 for this problem. But yeah, anyway, let's start. So we need to obviously take the input, which will always be a positive integer, and we can obviously add some text here. Please enter a number. So there we go. So this will take the input, just print out a message, and then turn that input into an integer, because by default Python obviously makes it I'm just wondering, yeah, okay, yeah, I did add an extra bracket. Yeah, but Python obviously takes strings as your default input if you don't surround it with anything. Anyway, so we have our input now. Now, when I look at this here, I'm thinking I'll need to loop over the number and obviously store it somewhere, like the sum. But also, I'll need to keep track of which harshad number I'm on. So am I on the first one, am I on the third one, is it the third one that the user wants, is it the fourth one, for example. Now for that I will introduce a count, variable. And also, we obviously need to store the current number we're checking to see if it's a harsher number. So we'll just make the current equal to 0. Now, actually we should probably make the current 1 because these are the first 12, so it would make sense for 1 to be the first harsher number. I mean 1 to be the current. Anyway, so now we need to do I'm going to do there's various ways of doing this problem. I'm going to use a while loop. So a while. Now what we're checking for is to see if the count is equal to the n. So we'll say while count is less than n. Just thinking, would that be fine? Yeah, it should be. Yeah. We'll obviously do some code here. So yeah, count should be less than n. Now we need to obviously store the sum. So I'll make another variable here called temp and make that equal to 0. The reason I'm putting it in the loop is because each time it goes through every number, it should obviously reset to 0 so that we can obviously check for the new number and check if the I'll rename this divisor. Yeah. Now we need to obviously loop through the number. Now in Python you can't obviously loop through a integer, but you can loop through a string or a list or a set or a dictionary, whatever. But I'm going to use a string because it's simpler. So what I'm going to do is I'm going to make a new variable called stringed current, which is the current as a string, and for we'll call digit. So for every digit in the string, just copy it, I'm lazy. For every digit we're going to sum up the integer values in each of them. So if it was 36, we're going to be 3, and then 36 is obviously a string, so 3 is a string. Make 3 into an integer and then add it to the divisor, and then do that for each value, and then we'll get 9, hopefully. we will. So we've got that. Now the other thing we'll need to check is if what's it called? If count, not count. If where is it? It's current. I keep forgetting. If current divided by 2. So what this double means is integer divide. So we'll divide by your specified number. I shouldn't put 2. I should put divisor. It'll divide it, and then I believe it will round it down to the closest integer. Now, if obviously it is a whole number, it shouldn't round it at all. So we can basically compare this to the current divided normally. So what I mean by that is here, if you have 30, if you have here the example, which isn't a harsher number, 15 divided by 6. Now I don't know what that is off the top of my head. Let me think. It's 2.5. 2.5. Now if we round that down, that's obviously 2. But 15 divided by 6, the actual value is 2.5. 2 is not equal to 2.5, therefore it can't be a harsher number. However, if in the other example, 300 divided by 3 is 100. And then if we just do regular division, so no rounding down or up, we still get 100. And 100 is equal to 100, therefore it has to be a harsher number. So that's the logic for this. Now, if it is a harsher number, we're obviously going to increment the count, and also let me think, count, just checking if I need to. I think here we should also make count equal to 1. Reason being is because actually No, we shouldn't. Because if our input was, if n was 1, and count is 1, 1 is not less than 1, so it'll never reach this while loop. Anyway, now the next thing we'll need to do is current plus equals 1, because we're checking for every single value, unless there is some like magical formula to obviously prevent this, but I can't really think of one. Yeah, this, and then when this breaks out of the loop, we'll obviously need to print our current. Now, I'm thinking I may need to subtract this by 1. I'll explain why in a second. Let's quickly test this though. Let me quickly close this. I was testing this earlier because I wanted to make sure I got this right. So, well, we'll test with 600. Spelling mistake. 600. 3103. Yeah, we do need to subtract by 1. So, reason we need to subtract by 1. Also, the answer for the test case should have been 3102. I did check this before recording this, so please rest assured it is 3102. I'll write it up here. 600 is equal to 3102. Now, the reason we need to subtract by 1 is because when we keep incrementing the count, after incrementer, we're incrementing by 1 again. So imagine we're on 3102 now. It increments the count, so now it's 600, but it increments it again to 3103. So we need to subtract it by 1. Or another thing we could do is we could replace the current plus equals 1 here and just put this to 0, because this will only happen if this condition is met. So if we remove this and just enter 3102, not 3102, 600, there you go, 3102. Now you can test this for other numbers, so 100th, there you go. And you can just search it online and check if you're right, but obviously in the exam you won't be able to, but another way you can check it is through their example. So the first 12 Harshad numbers, the 12th one was 18, so there you go. Yeah. So that's how you solve it. Yeah, so this was 2021 section B. Thanks for watching.